Hello everyone. Today we will discuss about data transfer schemes. Contents of the slides will be modes of data transfer and types of transmission. In the modes of data transmission, we have two modes to discuss and there are three types of transmission. We will discuss all these in detail. First of all, mode of data transmission. But data transmission means the flow of data, movement of data in the form of bits. Okay, data transmission means that movement of data or flow of data, and it occurs between two or more digital devices. What is the digital device? Digital device is the device which communicates in the digital form, means which process the digital number, which communicates in the digital number, and which produce the output in the form of digital number. All those devices are known as digital devices. Types of data transmission. As we discussed, there are two types, parallel and serial. The serial is further classified into two categories, synchronous and asynchronous. So first of all, we will discuss about parallel. Parallel transmission. All the bits of a byte. Byte is a collection of bits. 8 bits called one byte. Bits may be small रहेगा, bytes B will be the capital one. Okay. All the bits of a byte are transmitted simultaneously on separate wires. It means that more number of bits, the more number of wires. More number of wires. Which means if we are sending 8 bits, then 8 wires are used. If we will send 64 bits, then 64 wires will be used. Now in this case, as this diagram shows, there are 8 bits that are sending from sender to receiver. So here 8 lines are used. This is parallel transmission. Parallel transmission means the more number of bits, the more number of wires required. This diagram shows that 8 wires are used simultaneously to transfer 8-bit digital data. If there is data of 64 bits, then 64 wires will be used. Now, what happens with this? The data transmission process completes fast, or we can say that the parallel transmission is very fast. Because it transfers data simultaneously. Okay. Next, advantages of parallel transmission. First, all the data bits will be transmitted simultaneously. So time required for transmission of n bits will be 1 clock cycle. All the bits are transferred in a single time period. So n number of bits will also be transferred in a single clock cycle. That means this process is very fast. Second, due to transmission in only one clock cycle, clock frequency can be kept low without affecting speed of operation. Means the clock frequency on which the operation is executing, that may be low because that is not affecting the speed of operation. Speed of operation is happen only in one clock cycle, so it is not depending on a clock frequency. It may be low, it may be high. Disadvantages of parallel transmission. First, transmission of n bits will require n number of wires. Now, n bits and n number of wires. It will increase cost. It will increase cost. So, if we want to do parallel transmission, then it is very costly process. Second, with the increase of users, then it is very difficult to handle them. For example, 1 to 1 transmission is possible, 8 bit to 8 bit possible, but 1 to n or n to n, if n to n devices are there, then what will happen? There are number of devices and number of bits. So, huge number of wires are required here. Similarly, huge number of wires are required over here too. So it is very difficult to handle them. So these two are the disadvantages of parallel transmission. And to overcome the disadvantage of parallel transmission, we have serial transmission. Now what is a serial transmission? In this, only a single wire is used to transmit every bit. Only a single wire is used for transmitting n number of bits. How it is possible? All the bits of a byte are transmitted serially, one by one. Serially means one by one after another on a same wire. There is a single wire and this single wire is used to send the whole data together. In this diagram, only one wire is used to send the 8-bit digital data. Advantages of serial transmission is only one wire is used. It reduces the cost. Disadvantages: speed of data transfer is slow as bit by bit is transferring. Okay, if we have n number of bits, then it will take n number of cycles. Okay, there one cycle but n lines. Here one line but n cycles. So cost is reduced and speed is low. To cope up with the speed, there is a need of increase in the clock frequency. If we will increase the clock frequency, then the speed will be high or improved. Now we have types of serial transmission. Here we have two types: synchronous data transfer and asynchronous data transfer. Synchronous data transfer means at the same time, means the operation is performing on a same time. As the communication happens between two devices, both the devices are active at the same time. It is used in between the devices that match in the speed. Means, let there is a device A, there is a device B. If both the devices are match their speeds, nearly match, not exactly match, if their speeds are nearly match, then we will use synchronous data transfer. For example, it is used in between processor and memory. This type of communication happens between processor and memory. No start and stop bits are used. Means it's another logic of start and stop bit, which is number of bits are sending together, and start and stop bit, like this is start and this is stop. Okay, so here is no logic of mentioning this start and stop bit. This logic will be implemented in the asynchronous mode. Synchronous mode doesn't need start or stop bits. Also, there is no need of ideal time. Ideal time is a time gap between bytes. Like one byte is this, another byte is this, and here this is a time gap. There is no need of time gap as well, because all the bits are sending one by one. together sequentially and both the devices are active on the same time. So we don't need any start stop mechanism or any time gap to match their receiving and transmission. Clear? We'll see with this example like this. Here a sender, here a receiver. Sender is sending bit by bit, converting them in a block or byte. It can be called as a block, it can be called as a byte. 8 bits are together and this is sending. This 3 bits shows like the 5 bits of this byte has already been received by the receiver. This 3 bit shows that the remaining 5 bits has already been received by the receiver. Okay. Next is asynchronous data transfer. Asynchronous data transfer means at a regular interval of time. At a regular interval of time, it is used between the devices that doesn't match in the speed. For example, microprocessor and input-output device. In case of synchronous, processor and memory, here processor and I/O devices, because their speed doesn't match at all. To help receiver, start and stop bits are used. Start and stop bits are used in asynchronous mode. I will explain this in the next slide where we will discuss using an example diagrammatically. Idle time between the bytes are not constant. First, it is not constant and also it is used and it is known as gaps. It means there is a need of idle time. It can be constant, it may be constant, it may not be constant. Means maybe this time gap, maybe this time gap, maybe this time gap. It may be possible. Okay. Now see like this. Here the sender, here receiver. Sender is sending, receiver is receiving. This is a byte. At the start of the byte, there is a start bit mentioning bit 0. At the end of the byte, there is a bit stop bit known as 1. This 0 and 1 will tell the receiver that this byte has been received completely. Moreover, in between the different bytes, there are some time gaps. There are some time gaps. They may be constant, they may not be constant. Like here may be 1 second time gap, here may be 5 second time gap, here may be 1 millisecond time gap. It is possible. So what is happening? Why this time gap is used? Because it will specify that no more data is receiving, means the data you have just received is the complete byte. The data you have just received is the complete byte, and next if the data is starting with 0 after the time gap, it means it is another byte. Okay. Next is transmission mode. Now transmission mode will tells the direction of the flow. Transmission mode tells the direction of the flow, means from where to where data is traveling. Data is traveling, like there is a device A, there is a device B, A to B, B to A, or bidirectional. Such type of mechanism is known as transmission mode. It tells the direction of signal flow between two devices. Types of transmission modes. Here we will discuss 3 types of transmission mode: simplex, half duplex, and full duplex. Simplex, half duplex, and full duplex. Simplex mode. In the simplex mode, only one device can send and other devices will receive. Only one device will send and other devices will receive. Means communication is unidirectional. TV tower or radio. Example is TV tower or radio. Like your FM box will only receive the signal from the tower. Okay, so this communication mode is simplex mode. Half duplex mode. Half duplex mode means both the devices can transmit, but only one at a time. Means there is a device A, there is a device B. It can be sender, it can be receiver. Also, device B can be sender or receiver, but one at a time. If A is sending, then B will receive. When B is sending, then A will receive. Both the device can send and receive, but only one at a time. In case of simplex, the difference is A will always send, B will always receive. B never able to send. In case of full duplex mode, both the devices A and B, both the devices A and B can send and receive the data simultaneously. Means on the same time A can send, on the same time B can send. On the same time A will receive, on the same time B will receive. So this is known as full duplex mode. In this, simultaneous transfer is there. Both can transmit and receive at the same time. These are the references for my current slide. Ramesh's Gonka book, Muhammad Rafiq Usman, and Behrouz Faruzan. These three books I have read for these slides. Thank you everyone.